Okay students, welcome to the session number 7, programming session number 7. We will start the lesson right away. We'll move on to the slide number 2. Right, this is what we're going to discuss today. Today's session, we're going to discuss about introduction to Java. You will get a good understanding of the history of Java and things related to Java. The introduction part you're going to learn. Some new words will be introduced as well. Then features of the programming language, the Java programming language that we're going to learn. Actually, Java is described or introduced by Sun Microsystem with 11 words. So we're going to go through those words. I might be not explaining you all the words in detail, but some of the descriptions we will have to go through a little bit. Then we will be learning about what do you mean by the Java technology, what are the parts of that technology that we're going to use. So we will be basically talking about the programming language itself, what do you mean by the runtime environment or virtual machine, where to get it, how to download it, and why we need a virtual machine or a runtime environment. Finally, it is a set of tools, and we're going to see what are the tools that we're going to use and where they are situated in your computer, and so on and so forth. Latter part of the program, as usual, we'll be going to the question and answering section. Okay, let's move on to the slide number 3 then. Introduction to Java, right? As you know, Java is a very popular language nowadays, and by the time you're installing Java, you would get in the splash window saying that installed on more than 3 billion devices, not million, billion devices. So that much it's a very popular language, and all started like this. Actually, the photograph that you see in the slide is that the founder of Java programming language. He's James Gosling. I don't want to read the whole thing for you, right? If you want, you can read this one. His name is James Gosling, and he's a PhD holder. And by the time he was working in Sun Microsystems, in the second paragraph I have put it in a different color, Sun Microsystems, they were working on a project called the Green Project, and the idea was that project to build interactive TVs. By the time they were developing this language, the cable television companies were not ready for this particular technology, so that didn't turn up very well at the beginning of the development of the Java programming language. But nowadays, of course, Java runs on many types of devices, right? So James Gosling found this programming language, and he was belonging to the company Sun Microsystems, and by the time he was introducing this language, it was in 1991. Okay, 1991 they developed it. So these are the main 3 things that you need to know. James Gosling, Sun Microsystems, 1991. These are the 3 main things that you need to know about Java history or about Java. Okay, you can read further about James Gosling and basics of history of Java and all in Wikipedia, as well as in Google. You can search and get to know more information about this, and you can watch video clips and things about James Gosling, and he's doing these webinars and all in YouTube. If you're interested in, you can do that, right? So next slide number 4. If you move on to the slide number 4, I basically told about the green team. Actually, the green team consists of 3 people along with James Gosling. I think Mike Sheridan and Patrick Norton. These are the another 2 people who worked with James Gosling, along with James Gosling, in the green team. So you should remember, the green team consisted only 3 people. So they called them as the green team, and the project they were working also called the Green Project. As I told you, they were working on interactive television. That is why I put a very old type of a television. These are the types of televisions which were available by early in the 1990s. Okay, so these are the 3 people working for the green team. Then, and 1991, when the language was originally founded by James Gosling, it was named. Now when you find something, or when you have an invention, or when you have a new product, it has to be branded, it has to have a name. So the name that he used was Green Talk. Extension of the files were GT by then, Green Talk. Then again they revised the name to the name of the oak tree. Oak is the national tree of many European countries, like if you take Canada, like countries, like the oak tree was very popular, and it's like treated as a national tree. So they were going for that particular name. Later they found out this name oak is in use for oak technologies. So they then again they changed the language to Java. Actually, the name of the Java came from the brand of coffee the development team was having. So still that is available. That is why I include the packet of Java, that type of coffee packet in the slide to get you an idea, right? So no one is going to throw you any questions on this. So, but just a brief history or just understanding of what Java, how it was invented, so on and so forth. This is how it came, right? And Java was introduced with World Wide Web, and then it became very, very popular. Right, let's move on to the next slide. Next slide. In this slide, we will spend quite a few minutes understanding few things about Java programming language. Okay. The features of Java programming language, right? So when Sun Microsystem is describing Java, it is describing Java as, it will use all these 11 words or 11 terms in order to introduce Java. Okay, they will say Java is simple, Java is object oriented, distributed, interpreted, robust, so on and so forth. So you can see there are 11 words given. So anyhow, in this semester we are not going to learn all this information in detail, but I am going to do some extra sessions after your lessons. I mean, things which is necessary for the syllabus is covered. I will be doing some extra sessions, so we can talk about some more features, right? Okay, let me tell you why Java is simple. Okay, when it comes to a programming language, the complexity of the programming language is one aspect, whether developers going to prefer the programming language or not going to prefer the programming language. That's one aspect. So when it comes to Java, we say Java is simple. Due to two reasons, Java is simple. Okay, Java is simple, right? I can explain that to you, no problem. When you do Java, I'm going to share my screen, children. Hope you can see my screen. If you think this is your computer's memory, right? And you know, a computer program can run inside your memory. Let's say this is the computer program, and let's say this is the computer program which uses this resource. This is a resource that a computer program is using. Maybe it's an object, or it's a variable, or it's a data structure, something. This program is using this particular memory occupied area. It is using, this program is using, let's assume a programming language like C++, right? So what happens is, after you finish working with the program, what you do is you exit the program. Okay, you terminate the program, you exit the program. That does not mean automatically the resources and the memory locations it was occupied or it was using will be automatically erased. So the programmers or the developers need to write extra bit of codes. So in C++ we have things called destructors, just like constructors. In Java also we have things called constructors. In programming languages like C++, you have extra things that you have to do called destructors. The purpose of having that run is to destroy the resources that it has been using. So without that part, it won't clear the memory for you, right? So let's take a look at Java. Okay, the Java program will be working, right? And it also can use resources. It also can use resources. Now these resources, the program will make use of it. Program will make use of this. Right. Now when a Java program is finished executing, when the Java program finish executing, what happens to these resources is it is also going to left in the computer's memory. But what happens is the Java runtime environment, the Java virtual machine, we're going to learn about that in the upcoming slide. It has a feature called GC, which means garbage collector. Okay. Okay, the garbage collector is there. It's a program which is found inside the Java virtual machine. Time to time, this garbage collector will inspect this computer's memory uh, where the Java programs are running, and it will check any resources whether they are left out without being having an owner. If it finds something like this, what it will do is it will take that and take it to the what do you call, to the garbage collector section, and it will destroy that, right? Or it will take that thing. So that's what happens. So it will automatically take it there and it will destroy that for you, right? So that is how the garbage collection in Java happens, so that you don't have to write extra instructions to clean the memory, right? So because of that reason, because of that one reason, Java is simple to learn. Java is simple to learn, right? There's another reason why Java is simple to learn, which is called in Java, in some programming languages like C++ and all, there's a feature called inheritance, and it allows you to have more than one superclass to have one subclass. Using more than one superclass, you can have one subclass. So we will be learning about this one in object-oriented lessons. In real life also you will see something like, if you have a plane and you can have a boat, you can have a seaplane. In real life we would have seen seaplanes, planes which can land on water. So it has the features of sliding like a boat on the water, as well as the features of the aeroplane, both built in together, and you get a product called seaplane. So actually this kind of a concept of this kind of a things can be done by using more than one superclass. So subclass, superclass, child class, parent class, we have to learn these things. What I'm trying to tell you is, there is a concept called multiple inheritance. Multiple inheritance means, like this, we can use more than one superclasses to create one child class like this. So this is supported in languages like C++, right? But in Java it is not supported, right? So you might think, okay, that is a feature that is not available in Java, so Java should be not good. The reason is, multiple inheritance is very tedious, and it becomes very difficult for you to do testing and all, because same type of implementations of methods will be available in both the superclasses. Then sometimes it will be difficult for you to do maintenance of the code. So in Java this is not supported, this facility is not available. That also makes Java programs simple. Okay, that makes Java programs simple. Okay, let's talk about the other features of the Java programming language. Right, then Java is object oriented. I'm not going to talk about object oriented in detail, because object oriented itself is the lesson that we're going to talk in upcoming lessons. Because programming languages having, like for example, if we take the C programming language is a structured programming language. It's a procedural directly structured programming language. It did not have any features related to object oriented programming. to the C programming language introduced the object oriented facilities, became the C programming language became C++. Okay, C++. So C++, which means the object oriented version of C, having basically 4 features. There are 4 features available in object orientation. They are uh, abstraction, encapsulation, polymorphism, and inheritance. These we will learn about them in upcoming lessons. So if a programming language has all these 4 features, that programming language is known as object oriented programming language. So Java perfectly supports these features. So Java is an object oriented programming language. Java is distributed. When you are learning about Java, if you learn Java advanced way, there are certain packages. There is a package called RMI, called Remote Method Invocations. You would have seen applications like chat programs. Now if you have in a network in one computer, you can have the chat server installed, and you can install all the client versions of the chat messenger versions in all the client machines or in other machines. Then you can do the you can do the chatting work you can do. Or I can give you another practical example. Let me share the screen again and explain it to you. Let's say we have a tea collection center. This is the let's say head office or the main center, right? And these are collection centers. It's a, let's say it's a huge area. At the end of the day, the headquarters needs to know, right, what is the total collection of particular day. So a client version of this application can run on each center here, each head center, and they can simply update the database here in the headquarters. This kind of applications you can build. You don't run the same application here, you run the client version of the application here, and you run the server version of the application here. So same computer program, pieces of the program running in a distributed network like this. This kind of app can be easily built using a programming language like Java. So that is another feature that you have in Java. Right. So further we'll move on to the slide show again, and it is interpreted. Then you can see interpreted. Java is also compiled also. I will explain this one with the next slide when I'm teaching what do you mean by platform independent. So interpreted. So you know what is a compiled program and what is an interpreted program. Interpreted program means source code instructions need to be converted into machine code during the execution of the program. So that is called interpreted. But Java is not 100% interpreted. It is partially compiled, partially interpreted. We will talk about this one in the upcoming slide today itself. Then it is robust. Robust is a word which is used for powerful. It's very powerful. So robust programs are very tough. Java programs won't easily crash. There's one more reason for that one. Java programs are executed by a thing called Java virtual machine. It is like a dummy operating system or dummy computer inside your computer's memory. So once everything necessary for the runtime environment to run only, it will be perfectly working inside your computer's memory. So by the time your program is functioning, very rarely your programs will crash or your programs will stuck. And Java is a dynamic programming language, which this we are not going to do it practically, but you should understand programming languages like C, C++ uses files called actually header files. The extension of the header file is .h. I think when I was teaching about structured programming languages, I showed about Pascal screen and C screen. You would have seen we use something called hash mark include. Inside angle brackets we type stdio.h, standard input output header file. So likewise, there can be useful library files in other programming languages. Not every language is supported, but quite a few languages like C languages are supported. So Java programs can be made to make use of these libraries of other programming languages. That is why it is called it's a dynamic programming language. Then Java programs are also known as secured. The reason for why we use the word secured is, as I told you, Java programs are running inside an area called Java Virtual Machine, Java Runtime Environment. I will be going to talk about the runtime environment in the next slides. So you can't write viruses with Java. The reason is every instruction that going to be converted into binary and going to get executed are going to be verified by a program or a special feature called bytecode verifier. Bytecode verifier. After getting verified from this bytecode verifier only, the Java programs are executing. So for that reason, Java programs, we say they are much secured. In Java there is a type of programs called applets, which you can run on inside browsers. Even Java games can be built. Sometimes these games require to access local file systems, sometimes your sound card, so on and so forth. So when it needs to do something beyond its limits, always these are written or developed with things like requesting permissions. Like it will ask, okay, this program is requesting your permission to access the sound card. So if you grant permission only, then it can do that part, otherwise it will not automatically do the work. So it gives extra level of security when building Java programs. Then there's another feature called architecture neutral that I will be explaining in the next slide, because platform independence and platform dependence we're going to learn. For the time being, if I want to tell you what do you mean by architecture neutral or platform independent, you can develop the Java program once and you can run it on any platform. That means you develop it once, run anywhere, or any number of times you can run it on any platform. In order to execute Java programs, only one requirement is there, that particular platform should have the relevant version of the JVM or the Java Runtime Environment. If that is there, it can perfectly work. And Java programs are highly portable, right? So platform to platform, if you are doing development, like you are doing development work on Windows, then you want to do the development work on Linux, there is no code changes that you're going to do. Platform to platform, there is no extra coding or there is no changes that you need to do. So you just copy the project file on a pen drive, which was done in a maybe in a Windows machine, and you want to open it in a Linux machine and you want to do the project, no issues, you can simply do that one. So I strongly recommend that those who are doing development work, you can have Ubuntu installed or the Linux installed in your computer, and you can configure it with the development software that you want to do there, and it will be perfect. So Ubuntu is really perfect for development work. Okay, right, then it has high performance. And the fourth feature I was explaining, Java was interpreted. You might think, compared to compiled programs, interpreted programs run less faster. So we might think Java is slower. Compared to a real compiled program, Java programs might run slower, but Java is not totally a interpreted language. It is half compiled and half interpreted, so that it has very high performance compared to ordinary interpreted languages. Java programs are much faster. And finally, Java is multi-threaded. Multi-threaded in the sense, alright, let's explain that one also to you. I'm going to share my screen again. Right, multi-threaded. Let's assume this orange color box or the rectangle is your computer's memory. Okay, right, this blue color rectangle is your Java program. Right, and these green color boxes, definitely they are part of the Java program. They are part of the Java program. I'm going to call them as ABC. Okay, ABC. Actually, these are pieces of your code, pieces of your one Java program. This is your memory. That's your memory. Inside the memory, one Java program is working. Inside the Java program, there are three parts of the Java program. So the advantage of a Java program is you can parallelly, which means at the same time or simultaneously, you can execute this part, and execute this part. Let me tell you a simple example for you. Let's say you want to play a music, you want to play a sound file. Okay, so you will hear the music is playing. Then you have a name of huge name list, maybe let's say 5 million names are there. You want to sort them in alphabet order, A to Z order, you want to sort them. So that part is taking place. Okay, so let's say these two tasks are happening simultaneously. Not this sorting is not getting stopped, as well as this what do you call, playing the music part is also not getting stopped. So parallelly it can do multiple work like this. So doing multiple tasks or multiple pieces of the same program executing simultaneously is known as multi-threading, or a program having multi-threaded features. So a thread is a piece of a Java program. By the time we finish our sessions, if time is permitted after your sessions, which means the semester things, I will be able to cover these things as extra lessons, multi-threaded programs. It won't take much time to teach you, but we can't do it inside the syllabus. Okay, hope you got a good understanding of what is multi-threaded programming. Going back to the slide, so we talked about the features of Java programming language. I took quite a few minutes and I explained you what are the features of Java programming language. So you would have got a good understanding of what is that part is, right? Okay. Okay, let's move on to the next slide. We're going to talk about the Java technology. Okay, we'll talk about the Java technology. I think next slide number 7, we will talk about the platform independence and dependent thing. Okay, right, in this one we will talk about it a little bit. What do you mean by this? I think the order of the slides are a little bit changed. Okay, right, let's go to slide number 7, children. Let's do the slide number 7 first. Okay, now if you listen to me carefully, you will understand. Take a look at the first blue color rectangle, where you have two yellow color small rectangles inside it. So under that I have named it as Java Programming Environment. Java Programming Environment. Okay. Okay, if you take this blue color rectangle, which shows Java Programming Environment, so this is the area where we're going to do our development work. We're going to do the development work. So that means you are the source code, you're going to develop it here. You are the Java developer, you're going to develop the source code using your NetBeans or any other IDE. You can create your source code. Then you need to have the thing called the Java compiler, right? So that is what we need. Okay, actually once you install the Java software, right, if you go to slide number 10, I have given a screenshot, small screenshot, and I have mentioned, actually it says set of tools, but I have round two things. You can see Java C and java.exe. There are two exe files that you see on slide number 10. These are the two tools which are used to compile and run your Java programs. Actually the second one, which is Java C, is the Java compiler that you see. Okay, come back to the same slide again. So that's the Java compiler. So the program that you have created, the source code, gets compiled using that Java compiler. Once you do that one, once you compile that one, the outcome of the file, once you compile it, the outcome of the file, what you're going to get is the bytecode file. The bytecode file, that's what will happen. Okay, so once you compile it, the bytecode file will come. So it is also called the intermediate file. You're not going to get an separate file. You're not going to get an exe file. You're going to get a file called .class, right? Okay, so .class file will be there. That is an intermediate file. So bytecode instructions going to come. This is not in the development computers machine code, or it is not in the runtime, which means you're going to run it on a computer. It is not in that particular platform's bytecode. It is a platform independent code is what that is given to you in the purple color. So once you compile a Java source code using the Java compiler, what you're going to get is the bytecode instructions, a bytecode file. The extension of this file will be .class file. After this session, let me create a tiny program and explain you how it's done. Not using NetBeans, but using Notepad. I'll show you how it's done. Okay, right. Then the Java interpreter, the diagram I showed you again, the interpreter will read instruction by instruction from this bytecodes, and it will convert it into the particular platform's machine code. This is how the Java program works. Okay, so actually this green color box is where you need the Java runtime environment. It says execution of the program. Fine, that green color rectangle is the place where you have the Java runtime environment, which is the plugin that you have installed. If you have installed that Java virtual machine or the Java runtime environment only, you can convert these bytecodes into your particular platform's machine code, and you can have the program functioning. Now I have a Windows computer, then I'm going to create a tiny program and I'm going to explain it to you. So I'm going to share my screen to you. Right. So I'm going to start my command prompt first. Right. I will start my command prompt. I will minimize the slideshow. So I'll put the command prompt like this. Right. Command prompt is there. Right. This is my command prompt. DOS prompt. Right. So we will have a Java program created now. Quickly, I'm going to have the notepad. You can see the notepad is there. I will create quickly a hello world program and simply save it in a place. Here you can't auto generate the code. It's notepad, so you need to type the code. Okay, program is ready. Now we will save this program. File, save. I'm going to go to my D drive. Right, for the time being I will create a folder called Java Works. So I will go inside the Java Works folder, and I'm going to save this one as same as the file name, hello world.java. Right, I'm going to save this program. Right, now what I have to do is I have to compile that one. So I'm going to go to my command prompt. I'm going to navigate to the D drive. I type D:, press the enter key. Then I'm going to type cd Java Works. So I can go inside the Java folder. Then I can type Java C, right, the name of the Java program, and press the enter key and wait for a while. Now this command prompt does not know where the Java software is installed, so it is asking for me to set the path. So I have to say path, and I have to give the location of the this bin folder. So it's in path D drive program files Java JDK 1.8/bin. I press the enter key. Now if I compile Java C hello world.java, after a couple of seconds that will be ready for us. Right, now we'll go to the D drive and we'll see Java works, and you can see there are two files. One is called, this is the soft copy, or this is the Java code that I created, and this one has no preview. Actually, this is the .class file has got generated. You can open it on a notepad file and see how it looks. So I don't know whether you can read that. So this is what has got generated for this Java program. For this Java program source code, this is what has got generated by the Java compiler. So you saw that Java compiling. I just used this word, right? You can see I just used this particular word, Java C space hello world.java. This is what I used to compile the program, this particular program, to convert it into a bytecode version. Understand, this is not in any particular platform's version. It is a it is a intermediate code. It can be understood by any platform if we have the runtime environment. Now if I want to run this Java program, in my program I have installed the Java interpreter as well. I will type Java. Earlier I typed Java C, that is Java compile. Now I am calling the interpreter Java space, then I will give only the name of the program without any extensions, and when I press the enter key, I should be able to see the output on the screen. It says hello world, right? So I just wanted you to explain the mechanism, how it's working. That is why I took this practical example and showed you. Hope you understood that part. Okay, right, so let's go back to our lessons. We'll go back to the PowerPoint presentation. So so you should understand the blue color rectangle, the development PC. I have my computer where I am developing the computer program. So I am generating my source code. I just did. You understood that. You saw that. Then I have my compiler. I will compile my Java program using the Java compiler, and what I get is an intermediate file. It's not in any particular computer's machine code. It is an intermediate file, and in order to run this intermediate file, we need the Java virtual machine. In the Java virtual machine also, there's a specific thing called the Java interpreter, which is called the Java. So once you run through that one, it becomes the machine code, so that it can show the real output on your computer's screen, right? So that is why these two platforms are perfectly separated, like Java programming environment, execution of Java program. So I hope you would understand that. Right, now let's go to slide number 6. Quickly we'll discuss this part and come back to the platform independence part. Okay, when you talk about the Java technology, now when you say Java, what do we have in Java? Actually what we have is, first part what we have is the language, which means the programming language that you're going to learn, the codings that you're going to write, public, class, hello world. You're going to create these programs, these instructions. That is one part of your technology, the programming language part. Number 2, the execution part is there. Once you have created your programs, you need to run them. You need to get them executed on platforms. In order to do that one, you need to have a proper version of the runtime environment. The Java runtime environment is there. So you can separately download and install this one as well, right? So I'm going to talk about that one, maybe 2-3 minutes I will talk about that, right? Finally, you have to have a set of tools. That is what I have it in my slide number 10. If you go to the slide number 10, you can see a set of tools. Shall we quickly read that part and come? It says tools that are provided allow developers to create Java programs. So all these small tiny dust tools are used to get your Java programs created. So different types of Java programs can be created using these different types of tools. Mainly they include the Java compiler, interpreter, and other tools needed to develop, test, and debug Java programs. So even NetBeans software is indirectly using these tools That is why we have installed NetBeans software along with JDK. So it is going to use these tools behind the scene. We are not going to see them just like in the notepad or in the command prompt. You are not going to separately call them. So you're going to do it in NetBeans. So it is going to be a little bit not visible, but these are the tools that is going to get used. Okay. Right. Let's move to the slide once again. Come back to slide number 6, please. So in slide number 6, it says the Java language. So upcoming classes, that is what we're going to master. So that means we're going to learn the Java language very detailedly. So pseudocodes, up to now you know most of the pseudocodes, how to write them, different type of programs we know how to write them. So we're going to use Java programming language to do most of those pseudocodes, how to do them, and apart from that we're going to do some more Java programs, specific Java programs as well. Finally, we will be moving to GUI programs as well, so it will be interesting. So I'm hoping to build a small game, bug catching game as well. So we will see how we can do that part. All right, so this is enough for us now. So let me show you a small difference in here. Now let's say there are two people. One is the developer and there is another person called the end user. Now you are the developer, the programmer. You create the Java program and you have your the executable version, or that file. Actually we will be having a bundle called JAR file, Java files, where you can double click and execute that software. Double click and execute that software. In upcoming class I'll show you one or two this executable software that I have built. Now what will happen is this in the client's machine. Now let's say you have created a inventory control system, and in an actual hardware shop they have a computer, not a very powerful one, normal computer they have. In that computer you need to install this software. You want to have your point of sale or inventory control system which you developed using Java to run in their computer. So it's what you need to do. So let's see how to do that. So I'm going to share the screen again. So this time I'm taking my browser. Right, I'm going to do like this. I'm going to go to, you can type download JVM, right? So you can type download JVM, or yeah, different download things are given. So this is one link here, or let us GRE. Okay, from Oracle it's better to download from Oracle. So if you go, that is the people now owning Java. So now you can, still loading, right? So okay, so they have given these files here. Now if you compare this here, Java SE standard edition runtime environment, this is version 8, right? So for different platforms they have given the application here. A lot of platforms are there, you can see, and for starting from Linux up to Windows, that in alphabet order they have put. So you can see Windows, there are 3 versions they have. For 64-bit there are 2 versions actually. So what you can do is, let's say you have 64-bit machine, there is one here like Windows 64 73.73 MB. Actually JDK, if you are installing the software development kit, it is more than 200 or more than 180 megabytes it is coming. So this is a small file actually. 73.73 megabytes means this is only the Java runtime environment. This is the file that you have to download, and you can install this one in your client's computer, which does not mean you cannot compile your programs. You cannot develop Java programs if you develop this version, if you download this version and install. This is only necessary in order to execute Java programs. If you have a Linux machine, go download this one, okay, this particular version. Check your particular version of your Linux and get it downloaded. So once you get it downloaded, then in your that particular platform you can execute your Java programs. Here for Mac also we have, right, just like that Solaris and Windows platforms they have given. So Linux, Mac and Solaris platform. Solaris is operating system by Sun Microsystems itself. Hope you got an idea about what do you mean by the Java runtime environment. Okay, if you have any questions you can throw them in the description or you can throw them in the comment section below below the video. Okay, right, let's get back to the lesson. Right, so we discussed about this Java technology. Hope you understood that part, and we will be working with this one in upcoming lessons. Okay, let's move on with the slides. Right, I'm going to teach you a lesson called what do you mean by platform dependent system and platform independent system, because we say Java programs are platform independent. That means architecture neutral. Architecture neutral means it does not require a particular platform to run the Java programs. You can create the Java program once and you can execute the Java program in any platform that you like, provided that you have the particular version of the Java runtime environment. So here we will see how it is done. So if you take a look at this diagram I have provided, first of all we will understand what do you mean by a platform, right? I want all of you to look at, because I am not sharing the screen to you, I want you to look at, there is a section I have typed called Windows plus Intel. Down there I have typed AMD plus Linux. Okay, so if we take Windows plus Intel, actually Windows is the operating system, processor is the Intel part, Intel processor and Windows operating system. Then AMD is a processor and Linux is another operating system. So when you use the word platform, it is a particular configuration of hardware and software. The hardware part is your hardware part is your processor, and the software part is your operating system. Okay, operating system. So therefore, if you have a Windows operating system with a Intel processor, it is a particular platform, and if you have a Linux operating system with the Intel processor, which is a different platform. That is what you need to understand. So operating system plus processor makes up the platform. So that's what one thing that we need to understand. Now let's come from the beginning of the diagram. If you take that orange color source code, you know source code is the one that the Java programmer, you will develop this, right? This is not in Java, but please understand, it says in a normal compiled program. What happens in a normal compiled program like C or Pascal? What happens is I have shown in diagram. So you can see source code, you create your program, you will create the program, then you will use the compiler to compile it. When you are compiling, we directly use the processor to do the compiling. So what happens is the compiler will convert the source code file into now please look at that orange color 111 part and 0000 parts, so into that particular platform's machine code directly, or an exe file. In Windows and all, you get exe files. So source code, after compiling, directly you're going to get the machine code or binary code or native code. All these are same words. So that particular platform's machine code itself going to get generated after the compiling. So that is one thing. And down, if you take the light blue color one, if you take a look at it, you will see source code is compiled by Sun processor, right? Sun processor. Sun is another type of a processor. Then what happens is it is going to run on a Linux and AMD particular machine, right? So the idea that you need to understand is, here you can see it is providing you a different type of a 1-0 pattern. So it is providing for the same source code, it is giving you a different type of a ones and zeros, which means different type of a machine code. That is why an exe file, and you copy it to a pen drive, put it in a Linux computer and try to double click and run, it will say unidentified file system or unidentified file, error execute in the file. It does, that particular platform does not understand an exe file. The binary version or the binary code is not meant for that particular platform, so it cannot run on that particular platform. So in an ordinary programming language like this, if you compile it using a particular platform, it will require a Windows type of a platform to run, or it will require a Linux type of a platform to run. Then only you can execute the program. So these programs are called, or these programming languages are called, platform dependent. Dependent means it is depending on that particular platform. If that particular platform is there only, it will work, otherwise it won't work. Okay, this does not bother us because we're going to do Java programs. So once we will see how Java programs are functioning. So let's go to the slide number 9. In slide number 9, you will clearly see that in a Java program, so we say in a Java program I have written platform independent. Platform independent. So if you take that orange color, there are 3 rectangles. I have put Windows plus Intel, Linux plus AMD, future OS with future processor, right? In the future, if any new operating system, new processor is going to come, we will see what's going to happen as well. Okay, now we'll come back to the beginning of the diagram. You can see the source code, actually the Java source code, the Java program that you have developed. Once you create the Java program, you have to compile it. A little while ago I showed you the Java compile as well. So once you compile using your Java compiler, your source code, once you compile it, what you're going to get is the .class file. I showed that one also, visually I showed you. So the .class file will come. That is also called Java bytecode, also called intermediate code. All these are same meaning. So please remember this blue color thing what you have here. After compiling your Java source code, what you get is a platform independent code is what you have got here. This does not belong to any particular platform, right? Directly you cannot execute this bytecode file. You cannot directly execute this bytecode file. If you want to execute this bytecode file, what you need to have is you need to have an additional software, which means now if you take a look at the orange color rectangles, next to the orange color rectangles I have put a word called appropriate JVM. JVM is the short form for Java Virtual Machine. That's the plugin. Little while ago I showed you the downloading options as well. So if you have downloaded and installed this appropriate JVM in your computer, so there is no problem. You can convert this bytecode file into that particular platform's binary version. So you can see next to that again a blue color box is coming with a particular binary pattern. Okay, so if you take a look at the second diagram, Linux plus AMD, appropriate Java virtual machine is there, a different type of binary has got created. So same bytecode file is producing different types of ones and zeros. I hope you understand this one. So it is the appropriate Java virtual machine which is getting you the correct machine code or the binary code or the native code. So the source code is there, you are compiling it, and once you get the compiler done, you get the .class file, which is the intermediate code or the Java bytecode. If you want to execute the program, you need to have the interpreter, that is the Java, which is inside the JVM, Java Virtual Machine. That particular JVM knows how to convert the .class file into binary. So there is no problem, the bytecode file can get converted to binary. Okay, so you should understand here both things are happening in the software itself, because compiling is done by the Java compiler. Though you use an Intel processor or whatever, it is compiled by the Java compiler and you get the .class file. And when you want to execute it and you want to get the binary version, again you use the JVM, right? So this is what the basic understanding of Java, why it is platform independent, also known as architecture neutral. Architecture neutral. Okay, let's move on to the next slide then. So slide number 10. Actually we already discussed about this slide, children. So set of tools. Now Java comes with the set of tools. So we can go further. Next slide is about the question and answer session. So if we have any questions, we're going to talk about them. If you don't have any questions, then we can wind up the lesson. Okay, If you like this video, please give it a like. If you didn't like, give a thumbs down, and please do share with your friends, and please subscribe to the channel if you haven't subscribed. Thank you very much. See you in the next video.